So we can have objects that are, as long as they're still inside of the sphere, but they may not be right next to the box, or right next to the ball, they'll still be affected because they're within that radius of the impulse. Now, of course, we could up the strength here. So if we add this, increase this to 10,000, you'll see that very quickly this is going to actually add a very strong impulse. So these things can really get blown away. So it's almost more like an explosion of sorts. So that's pretty cool. But I'm going to show you now what happens when we uncheck velocity change. With velocity change unchecked, now the mass of the objects matters. So if we come up and hit O, it's not really going to do much because each of these objects has its own mass. So we're going to have to up the strength of this to quite a bit. So we'll add another couple of zeros in there and see if this affects it. And so if we come up here and hit the O key, okay, so now that's affecting it. But I want to show you something really key, and that's how the mass comes into play of these boxes. So what I'm going to do is I'm going to drag this box over here. I'm going to drag this box over here, drag this box over here, and that way they're all sort of away from each other. I'm going to actually get it so that some of these boxes are sort of off to the side. And so what I'm going to do is I'm going to take this first box and I'm going to come in here and I'm going to drag down on this little menu here and type and click on static mesh component. And in the static mesh component, you'll see in the physics section a mass in kilograms. And it's by default set to 442. But you can check on mass in kilograms to overwrite this. And instead of 442, this is a number that's calculated based on its size and density. We can change this mass to something lower. So for example, I can change this to, instead of 442, I could change it to maybe 100. And then this one over here, I'd like to change this one to 200. And then for the next one over, I'll change it to 300. And then the others will leave at their default of 442. So basically what we've done is we've changed the mass of the first box to 100, the second to 200, and the third one to 300. And then of course these ones are both 442. So let's see what happens now if we roll over to the first box over here and we hit the O key. And that gave it a good force that it sent it flying. Now if we come over to the second one, you'll see that it's not quite as strong. If we go over to the third one, it's again not quite as strong, and then we come over to the others and they're also not as strong. So basically the lower the mass, the more dramatic that explosion or that force is going to affect it. And so with velocity change, you can have things that are basically with velocity change unchecked rather, you can have an impulse that will affect it and take its mass into consideration, and it will be more physically realistic. Whereas if you check velocity change, it will ignore that mass. Mass will have no effect, as you can see in the comments here, or in the tooltip. Mass will have no effect. So with velocity change checked, in general, the strength will not need to be as high. But with velocity change unchecked, you'll need a pretty good sized force or strength of the impulse rather, and then you're going to need to start worrying about the mass of your objects, because objects with a lower mass, such as this one here, they're going to be affected much more by the blast or by the impulse than say something like these objects over here with a 400 instead of a 100. So that's one thing to consider. Now, a good check that we can do with this physics ball BP is we can check to see if each of these static mesh actors is simulating physics. Now let's go back over to the boxes here. I'll select one of them and I'll come down to the physics section in the details panel, and you'll see this simulating physics checkbox. So if we uncheck that for this particular box and we hit play, we can come over to it and hit the O key, and you'll see that that particular box no longer gets pushed away when we hit the O key because it's no longer simulating physics. And now a good check to make, just so that we're not calling a physics simulating function on an object that's not simulating physics, is we can check to see if it is simulating physics. And we can do that by taking the static mesh component, dragging off of it, and typing is simulating, and you'll see is simulating physics. And if we click on that node, we'll see we get this is simulating physics, and we get this return value. And if you hover over it, you'll notice it's red, and if you hover over it, it'll say return value Boolean. And Boolean is the type for this particular return value. It has the type of Boolean. So remember, we've learned about the float data type, we've learned about the string data type, we've learned that some objects have like an actor data type, and this particular node is returning a red Boolean. Now that's the color coding for the Boolean. Now a Boolean is a variable type that can have one of two values. A Boolean can either be true or it can be false. Those are the two options that it can have. So like a float variable can have any number of potential values. It can have the value of 0, it can have the value of 1.2, and so on. But a Boolean can have only one of two choices. It can be true or it can be false. And the reason is because a Boolean is used to determine whether or not to do something in logic. So for example, this add radial impulse will need to be called if simulating physics is set to true, is basically checked on that checkbox here in the physics category. If it's set to checked, then this node will return true. But in the case of this particular box, since it's not checked, this will be set false. And so this check can be used to determine whether or not we want to add radial impulse. So how do we do this condition? Basically, how do we use this Boolean? And we use it by using what's known as a branch node. So if you right click and you type branch, you'll see that we get this branch node. And we can drag in the input execution pin, and we have two possibilities that happen depending on the condition. And notice the condition here takes a Boolean value. And so this will allow us to drag in what's returned from is simulating physics, and we drag that into the branch, and this will return either true or false depending on if this static mesh component is simulating physics or not. If it is, it will return true, and what will happen is the branch will execute the true branch, and if it's false, it will execute the false branch. So what we can do is plug the true branch up to add radial impulse, and that will then only work for static mesh components that have simulating physics set to true, which for this particular box will be false. Now we can do something else if false, or we can just do nothing. And just to do something, I'm going to drag off and do a print string node, and I'm going to type static mesh not simulating physics. And so that way we'll have two different lines of execution. One will happen when the static mesh is simulating physics, and the other when it is not simulating physics. And so let's go ahead and hit play and see how this works. So if we just come up and we just kind of come up to a static mesh here and hit O, then we get the impulse applied. But if we come up to this one and hit O, not that one, this one, we'll get that message printed to the screen, static mesh not simulating physics. Now of course we're not going to get that when we come up to objects that are not even generating overlap events. Remember, these boxes over here, they're not generating overlap events. If you click on them and look in physics, you'll see, or actually collision rather, you'll see generate overlap events is not set to true. So in here, when we press O and we get overlapping actors, these actors over here are not even considered to be overlapping because they're not even generating overlap events, and so they're not considered to be overlapping by this get overlapping actors node. Now if we come over here and we set one of them to generate overlap events, then we can come over here and we can hit O, and apply the impulse to that particular object. But it's not going to work on this one here, this other box that was not being affected, because it's not generating overlap events. It doesn't participate and get overlapping actors. So that's an important distinction to make. Okay, so that is a good check that we can use, is simulating physics, and that returns a Boolean. So remember, the Boolean can have a value of either true or false, and the branch node will execute one line of execution if the Boolean being put into it is true, and another line of execution if the Boolean being put into it is false. Now if we break this line, you'll see that this condition can have a default value. Checked is true, unchecked is false. So if we leave it checked, then it'll always execute the true. If we uncheck it to false, it'll always execute the false. And so that is another way to use the branch node. And then just a little piece of bonus information, you can create a branch node not only by right-clicking and typing in branch, but you can also create one by holding the B key and simply clicking, and that will add a branch. And that's because branches are so common that a hotkey was created to just hold B and click. So that's another way to create a branch node. So this is going to conclude this video. We learned a lot in this video. We learned how to get overlapping actors, how to filter them and only get specific types of overlapping actors. We learned that that returns an array, which is different than a single value. It's a collection of values, and we can access that collection of values with a for each loop, which will do something on each of those elements in the array, each of those values. And we get those by getting the array element. In this video, we cast them to static mesh actor, and we actually check to see if that static mesh component is simulating physics. If it is, we use a branch to see if that is simulating physics returns true or false. If it returns true, we call add radial impulse, and if it returns false, we simply print a string. And on add radial impulse, we learned that the impulse takes an origin. That's the origin of the, you can think of it as the blast. It takes a radius, which is sort of like the blast radius of an explosion. It takes a strength, and we've learned also that checking or unchecking velocity change will determine whether or not the radial impulse takes the mass of the particular target into consideration or not. And of course, the target we used was the individual element of the array, in other words, the static mesh actor, and of course we got the static mesh component of that actor. And so what this will do is loop through each element in the array and call add radial impulse for each of those. And this all gets called in a single frame. So that is quite a few different concepts. So if you had to rewatch this video an additional time, that's okay, because we introduced quite a few different concepts. But now you know about basically a little bit more about overlapping. We know about simulating physics. We know about adding impulses, and that each object has its own mass, and we can change the mass. We can choose to take that mass into consideration or not. And we basically learned that the for each loop is for using an array and looping through each element in that array. So a lot that we learned here, and so in the next videos we're going to get into some even more interesting stuff. So stay tuned.